So what do we mean when we say all programming is metaprogramming? What are metaprogramming and reflection? They're $20 words. It should make you feel smarter to use them. But reflection means we can ask an object questions about itself at runtime. We can have it modify itself at runtime. And metaprogramming means when we write code whose job is to write new code that at runtime actually causes interesting things to happen. So the question is, are these just $20 words to make you feel smarter, or do they play some role in making your code more dry and more concise or otherwise easier to read? And of course, I wouldn't be explaining it unless there was an affirmative answer to that question. So to illustrate it, let's modify our bank account to make it international. We want to be able to deposit other currencies. So we can already say deposit $100. It'd be nice if we could deposit, let's say, euros. So we could deposit euros to dollars 20. But that's pretty ugly. That looks like something a programmer might write. 20 euros is like a dollar in today's currency or something. OK, so that's ugly. What else might we do? If we were in a traditional object-oriented language, we might be forced into something like this. Instantiating a currency converter. Yeah, I know, right? Groan with me. That's terrible. So that's not beautiful. We're all about trying to write beautiful code. So what would we like to be able to say? What would be a more readable version of what we want to do? Well, that's dollars. How about that for euros? That's pretty clear what you want to do. And this is no problem in Ruby, because one of the nice things about a dynamic language is that we have open classes. That means that we can modify, not only creating our own classes, but modifying and extending the classes that Ruby ships with. So how would we do this? Well, we already know everything is a method call, right? So if we write this, we're saying that euros must be a method that we can invoke on the receiver 20. That makes it an instance method of the numeric class. No problem. We open the class. We define our euros according to an exchange rate that is what we call the good old days in the United States, and we're done. Does this really work? Well, let's try it. OK, I reopened the class. I added a method. Pretty cool. OK, but before you gasp in further astonishment, let's go further than this. What about that? What about that? This is problematic because our function is called euros, not euro. Well, there's a dry solution to that, but to motivate the solution further, let's try something even more ambitious. Let's go beyond that and say, I also want to support other currencies. But it'd be kind of wasteful if all I'm really dealing with is a list of currency names and conversion factors. I don't really want to write n separate methods that look like my 3-line method. So surely there is a drier way to do this. So there is, in fact, a drier way to do this, and here's one possible solution. I've reopened the class numeric just like before, but now I have a more general, here's my hash, which just maps currency names to conversion factors. No surprises there. This is the cool part. One of the facilities in Ruby is called method missing. So method missing gets called when you call a method on the receiver and the receiver doesn't know any method by that name, but if you've defined a method called method missing in your class, it will receive the call instead. And method missing is passed up to 3 arguments. The first one is the actual name of the method you tried to call, but which doesn't appear to exist. A list of the arguments that that method would have received if it existed, and optionally a block. We'll learn a lot more about blocks shortly, but because most Ruby methods are written so that they can take a block as an argument, there's the possibility that our method could be allowed to as well. So what method missing does in our case is it looks at the method ID, converts it to a string, gets rid of any final s. Remember, we had the problem of wanting to be able to call 1.euro as well as 1.euros. So we're basically going to canonicalize the name of a currency to its singular. And then we just ask whether we already have a key for that currency, and we convert it. Minds are slowly being blown. I can feel it. I can feel it from across the screen that minds are being blown. Let's actually see what happens here when we do this. I will copy that code. I'm back in the interpreter. So what's going on here if I do something like this didn't work, right? So what went wrong here? Well, method missing got called, right? In fact, the debugger is helpfully telling us that where things went sour is in method missing. And here's my method missing that I defined, and here's the problem right here, right? We don't have a key in our currencies array for pound, so that fails. And when that fails, what happens? then I try to basically punt up to my superclass, right? As in all object-oriented languages, there's the idea that if you don't have a function, but your superclass or one of your ancestor classes does have it, it gets control. Well, Ruby has the same thing, with the difference that method missing is called first. So before my ancestor gets a chance to handle it, I get a chance to handle it using method missing. So this is a nice extensible way to do the thing that we were trying to do before. Get it? Dry? So what does this mean? Reflection and metaprogramming are not just these fancy big concepts, right? You can ask Ruby objects questions about themselves at runtime. For example, method missing gets to look at the name of the method that would have been called and the arguments that that method would have received. We can use that information to generate new code at runtime. That's what attr_accessor is exactly doing, right? It is creating on the fly getters and setters for instance variables, which means you can have code that writes code. And as we just saw, you can reopen any class, whether it's your own or whether it's one of Ruby's built-in classes, at any time, and you can add stuff to it, or you can modify what it does. Now, one of the things about Ruby that when I first explain this to people who come from another language, one reaction that is very common is, oh my gosh, that's chaos. You mean you could reopen any class, and if I'm working with somebody's code, I don't really know if a string is a string or if it's a special kind of string, and if I call a method and they've got all kinds of method missing hooks, then I'm really not calling the method that I thought I was called. That's chaos. So here's my message to you. You're all grown-ups. At least I assume most of you are grown-ups. And with great power comes great responsibility, right? Any language that gives you enough rope to hang yourself demands that you have a certain amount of taste in when it's good to do this. If in doubt, you can ask somebody who's more experienced. You can look at other people's code. And it's true that there are some abuses of these features, as there are with any good features. So any good technology can be used for good or evil purposes. We will try to present examples of good purposes that lead to beautiful code. But things like code review, pair programming, and so on are going to help us avoid some of the worst excesses that would lead to poor uses and or abuses of these features.